It's that time, 6 p.m. Sunday. Welcome to Steve's Place. Tonight we will have a really fantastic guest here who is going to teach us all about the ionosphere and the threats that we face every day. And for those who are not in the know, the ionosphere is vital to all life. And if it ever goes away, it'd be the end of human life as we know it. But in the meantime, I'd like to remind everybody we do have videos from last year's conference. Just go to testofTech.info and click on this logo here, and it will take you to this page here. And on this page here, you can order last year's conference as video on demand. It's $99, one-time fee forever. You know, you own those videos once you buy them. And we also have T-shirts for sale there. And for those who want to help us out in that with our various projects, you click on the green button there and make a donation. You know, and this will be over on HowTube. You know, and also I'd like to remind everyone about our Test of Tech YouTube channel. Right now we have over 14, close to 1,500 videos up there. Many of them are free to subscribers. It's free to subscribe. And what subscription gets you, it notifies you whenever we put videos up there. If you mark the announcement things, so you get notified. Right now we have all the extraordinary technology conferences up there, except for 2024, and that'll be on HowTube. And then we also have most of the global science congresses. I have one more to go. I got to set my DVD recorder back up so I can transcribe them or convert them into video files. And then we'll be starting to put up the coffee files later after that. And I also want to remind everyone we also have a membership. And for members, it's like $9.99 a month, and it gives you access to all 1,500 videos. You know, and there's a lot of videos up there with people you will never see again. And once I get the coffee ones, I'll be working on. I got a bunch of Tesla Society material I'll be putting up there. A lot of these people are no longer with us, and so this is probably the only place you'll be able to find these at. And if you go to the main page, testofTech.info, to the yellow box, you notice we have like the general Test of Tech channel, which gets you the general page. But the thing I want to point out is the conference directory and speaker directories. You can click on a conference directory and it brings up all the conferences that are up there. You click on the YouTube logo, it brings all the videos associated with just that conference up there. So you can see who spoke at that conference and have access to any of the fields. And we're doing the same thing with speakers. So you can click on a speaker and you'll be able to see everything that speaker has. You know, so I encourage you to become a member. You know, and for $9.99 a month, it helps us keep the lights on. You know, and put together our conference. Our next conference is going to be August 6th to 10th, and we'll be putting some more material up here starting next week. Anyway, I'd like to encourage you all to give me a call if you want to register. Right now, we have a 30% discount. If you sign up 2 or more people, I can give you an extra 5% off. So give me a call and make your arrangements as soon as possible. Now, without further ado, let me bring up Dr. Michrowski. Welcome, Andrew. It's good to see you. And
thank you for having me.
Dr. Michrowski has spoken at a couple of the Tesla Society symposiums in the past.
Yes.
If you ever get a chance, get the 1986 proceedings.
Yes.
They're hard to find, but he has an excellent paper in there on the mechanisms of human consciousness, which I found fascinating. But tonight he's going to be speaking on the ionosphere, and he is an expert in all the fields of EMF including EMF pollution, both in the ionosphere and in actually your ambient uh, place where you work or live. Anyway,
I
and
live
what
in
else?
Ottawa, Canada.
He lives in Ottawa, Canada, and is the president of PACE, the
Okay.
Planetary Association of Clean Energy, which has
Okay.
been around 40 years or more.
Oh, more than that. It's since we've been informally since 1973, and we were formally since 1979.
Okay, well, without further ado, I'm just going to turn it over to you, and you can talk about
The threats to the ionosphere. Okay. So next slide. Okay, so the context of the ionosphere is that we're part of the solar system. The sun emits energy in all forms, and when it approaches the Earth, there's a shockwave response, which makes that the energy starts through the planet, passes through the North Pole, and then is released from the South Pole. There's a little interesting fact about this input and output is that part of the input is hydrogen alpha atoms, and the Earth gives 8 times more hydrogen alpha atoms back to the sun. So we seem to be as a living system, not just as a planet, but as a living system, provides something back, feedback to the sun. That's very interesting. Now the shock bow effect also makes it that there is and that's the picture that we see there is what happens at midnight on the North Pole. But there's also a plume that goes out, stretches out to other planets, especially to Mars and Venus. And if the moon intervenes in between or passes through that plume, there are going to be effects to and from those planets. So it's really an interesting dynamic, very complex, and was first noticed when the first satellites were sent out into space. So that's the context. That's the world that we live in, and if you see the side bands, these are part of the magnetosphere, and they shield us from the more intense and more difficult to live with emissions from the sun. So, next slide, please. So there's more detail here, and among the dynamics that occurs within the near this planet uh, is there are lots of electrodynamics going on there, and the magnetosphere, which we see in the lower image, is basically charged particles, electrical charges that protect. Now, what is at issue in modern times is that because we put so many things out into near our planets, all those satellites, for example, um, they are disintegrating all the time, and they are um, constantly issuing debris that is making that those green bands that you see in the lower part uh, lose their capacity to protect us. That's basically the thing. Okay, next slide, please. Uh, Here's just an image, it's just an imaginary image, just showing that everything is in constant flux, all kinds of things happening around the planet. That's a natural thing in part, but we are now adding on new things to the dynamics. So there's all kinds of perturbations, natural and otherwise. Next slide, please. Okay, so here's more detail about man-made interventions from satellite ablation. So the ablations mean that there literally are like surgical removal of debris. It can be all kinds of things, plus the dissipation of the satellites themselves and the entry and re-entry. So every second, the space industry is adding 2,000 times more conductive material than the mass of the Van Allen belts. These are the blue belts that you see in the ionosphere. And this affects what's called the debye length, the distance over which charged plasma may shield an electric field. So so now we are constantly adding much more space stuff into the ionosphere above us, and we're accelerating the perturbation. The debris itself and the reentries of all kinds of things further disrupt planetary protection. And that is how much, that is not very clear at this moment. So now there's another problem too, which is not spoken to by people who look into this, and that is that when the satellites have been sent out for telecommunication purposes, it was they were engineered to only give up so much microwave emissions, but the actual emissions it produces, and for an unknown reason, are actually amplified quite a bit. So even whatever might have been well planned through, thought through by some scientists, is not in fact what is happening. There's much more coming out of these satellites in terms of microwaves than thought. Now, the bottom image shows what is a dBi length profile. So it shows you the sideways and from the top. So there are some very strongly ionized parts, and then weaker, and there are all kinds of variations of the theme. But this is all changing because of the presence of more and more stuff. Now, there is an interesting side note to this too. Way back in 1917, I'm sorry, a man called Rudolf Steiner, that you may have heard of, projected that if there were a ring around the planet, which is we have a ring of lots of satellites, but if they were connected or conductively connected, that would be a source of energy to supply all energy requirements of the planet, for running machines and so on. Thank you. So next slide, please. Now, there are other things that occur besides what's produced by satellites and stuff like that, and that's spherics. And they themselves are produced by any telecommunications. They became a very big issue in World War II when the United States was very involved in worldwide provision of aircraft, and they created all kinds of noise and radio communications problems between planes, or even guidance to planes as they flew around the planet. And that became a big issue study for NASA later on, and other military scientists who were calling this whistlers because they would create these problems. Now, the images that you see, one is the reds are the noise that comes from the ionosphere with any communication that occurs, and then depending on the frequency, and then you have an image which is a time-lapse image, like if you turn right on the bottom image, you see every second a little change of variations of different frequencies. Now, we're now creating more spherics, and we've been doing that since more or less World War II, really. But what happens is that many people who are weather sensitive or feel pain are very stressed by this, and consciously, And of course, I've noticed since I've been studying several thousand people who are environmentally sensitive that in recent events like the eclipse that we had last year and the, the solar flares that we're experiencing now and this for the last few months, many people are reporting much more severe uh, pain or discomfort than before. And that's because we can say that in addition to all the satellites that are now in the debris in space, we are also having an augmentation of telecommunications, and that is creating more, making our planet less capable of protecting itself from other things like the solar emissions. Next slide, please. Now, in addition to all of this, there is also plasma. Plasma is basically uh, volumes, if you wish, of charged particles uh, that has not been known really before, and they are called the Birkeland currents. They were predicted about 70 years ago by a Swedish scientist, Alfvén, but they were actually found to be true. So you have field-aligned plasma currents and electric double layers that surround the pole, and they also have, and, like this is shown on the top one, called region two, so on region one. They come in and they remove, and there's sort of a circumpolar type of thing. Also, now I suppose that's something that I was very surprised to see about 15 years ago was that, and even we experience it right now in the United States in these days, uh, is something called the polar, um, well, anyway, polar wind or circle, which starts, it's like a jet stream that starts from the North Pole area. And that never existed before, as far as I know. But it is now coming more and more frequently and can propulse very massive amounts of cold towards, say, like the United States at this today. So and yesterday. So uh, that may the reason why this has enough energy to do to go that far south as to the United States may be because we have less protection from our ionosphere now. And there's a little more detail shown of what these currents could look like in the image below. Okay, thank you. Next slide, please. In addition, we are sending all kinds of man-made chemicals, geoengineering brews, fossil fuels, nanoparticles. The nanoparticles are a newer thing in the last 10 years or so, and they also alter the ionosphere conductivity and can induce weather-associated patterns. Now, what is very alarming is that some of these things that we send to space, just by the way we do things and the decisions of politicians, is that they develop aerosols that actually create lifelike structures. That is, they're animated and they can be breathed in or they can enter our skin and so on. And that is a totally unknown area of research and could be very dangerous for many people on Earth. So the stuff that we send include barium, nano-aluminum coated fiberglass, known as chaff, radioactive thorium, cadmium, chromium, nickel, desiccated blood, mold spores, yellow fungal mycotoxins, ethylene dibromide, and polymer fibers and aerosol nanoparticles. And they, besides interrupting the quality of things for life, they also play a role. I do not know what percentage of it, of changing the nature of our protective ionosphere. Next slide, please. Now, it's very interesting and it's appropriate for the Tesla Tech effort to look into Nikola Tesla's experiences with the ionosphere. Now, the middle image that you see, the top middle, is the Colorado Springs laboratory that he had in 1899 when it was finished. And he did many things there, but those that are pertinent to our interest in the ionosphere is that he managed to make not only wireless transmission of electrical energy and see how the planet responded to it and see what kind of pathways there are for movement of energy throughout across the planet, even at different heights of the planet, but also he made actually columnar emissions vertical into space to different heights and would excite them. And that's how you notice that there were different colors. There would be green, there would be blue, whatnot. And from his knowledge of chemistry, he would understand that they would represent the presence of different things like, for neon lighting. And as a matter of fact, that aspect of research has not been very much published. Was a gift that he made to one of his colleagues who worked with him in this New York laboratory later on, the man called Claude Néon. And he was a young French expert of fusion electricity, learning from Tesla, like Marconi did later on, learning from Tesla as well. And he said, before you go back to Paris, I'll teach you how you can make fluorescent lights and how you can make all these beautiful neons. And that was all learned from his experiences of going to different heights of the atmosphere and towards the ionosphere. Now, so the nature of his columns that they were helical, and they were tunneling, and they also taught him something that he was able to explain to others around 1920, 1930, when there existed in the United States an excellent radio engineer, a scientist, who said that from his experience working on military antennas, like between United States and Europe and the United States and Asia, was that there was described by this scientist something that there are waves that exist between the earth and the air, not all on the ground, not all in the air. And these waves eventually have a name for them. They have no radiation. Basically, that means they're like field-free electromagnetics or scalars. So Tesla was very happy to speak out to the several scientists in the United States, very highly regarded by the military, that hey, you're now describing what I've done. So anyway, and now in the images, that was the central image. The image to the right is his Warden Cliff tower that he made for J.P. Morgan, and was functioning around 1901 to 1902, just a few years after Colorado Springs. And its purpose was to use certain applications that it learned in Colorado Springs. And one of them would have been the transmission of electricity from Niagara Falls, amplified through the magnetosphere, at least tenfold, and then sent around the world for commercial purposes, as well as a sort of clock that would work 60 cycles per second for a unified time system, and many other features. Now, the bottom images from Colorado Springs are two ways that he was able to demonstrate the transmission of electricity without wires at a distance. And one is a series of 3 low bulbs on the ground near his lab that were lit just by having a little antenna attached to them. And the other image is a more sophisticated system, very relevant to today's science, and that is using coil, actually three winding coils with no with a top with no connection to anything, just in free space, and in the bottom there's a ground, and actually it's a trio type of situation, which could collect electricity for that little. Actually, it's a very big lamp on below. Okay, so I think that lamp would be like 1,000 watts, for example. Okay, next slide, please. Oh, I'm very surprised. Okay, so there's one. Okay, there's something missing in the slide here. That was an article that we published in 1970 about the Norwegian atmospheric research system that was made, and it was work in Tromsø, northern, which would beam microwaves through the ionosphere with 100 microwave per pulse at 100 to 500 cycles per second. It was penetrating the atmosphere, and they would watch and control electrons and plasma vortices structuring. And what is interesting is that that station in Tromsø continues to work here and there once in a while. And an image that you see to the right is an actual result of the kind of emissions being sent from Tromsø to the sky. And this system that you see there was actually also seen in similar way for 2,000 or 3,000 kilometers away in the mid-Russia, Russian Federation, that same day. So I think that image is 2019. So I bring that image to the fore because it also illustrates how beaming in the ionosphere or towards the ionosphere comes in this type of responses. So it's a vertical, you have vortices and you have transverse waves, not the Hertzian propagation. I regret that what we are showing elsewhere is not including notes that are below. So when people if they ever get the PDF version of this show, they'll be able to read the text and the citations for everything. Next slide, please. Now, there's more recent ionospheric research, and I'm just bringing out one. As a matter of fact, I think we must have several, at least a dozen, if not more, research facilities that are trying to beam in one way or another to space or inside, parallel to the planet or vertically. And one of them is a project that was supported by United States Congress, and by which the United States Navy between 2013 and 2019 would conduct all kinds of microwave research and experiments, mainly to see what military value there could be. Now, in one of the earliest experiments that were done, which also included mobile units, like little pickup trucks with trailers, made such a massive microclimate situation that about 100 huge old trees fell down in the Olympic Park. Now, following that experiment, the United States Navy asked the United States Forestry Service if they could continue doing such research, and they did. But also, this was part of a program which is shown in the map on the other slide, whereby certain parts of the west coast of the United States, and you see these protected areas, and on the east coast would be subject to experiments. Now, I suspect that for the east coast of the United States, there may be some experiment going on now, which causes a very unusual pattern. I'm sure you've all heard how hurricanes are developed from West Africa. They go through the equator, and then they tend to go towards the Caribbean, and there are different pathways, and eventually they may hit parts of the United States and Canada. Now, since about 3 or 4 months, there are strong storms that do not hit the United States or Canada, and seem to go straight up to the Azores Islands and then bend towards Europe. And you must have heard, and I've seen at least 10 such storms, very big systems. They're as big as equivalency of Gulf of Mexico, or as Trump would say, Gulf of America, all the way up to Greenland, that type of size of storms. Well, they're now deflected. They go up past Bermuda and then turn to the right. And of course, one result of this has been a constant number of storms that hit Ireland and the United Kingdom, storms that have never been seen the like for at least 100 years of weather history. So what may be happening is the American Navy might be just testing, is there a way of protecting the East Coast from storms? Well, maybe they have, but one result of that is it's hurting somebody else. Okay, next image, please. Now, the other thing is part of the problem is the way we use our cell phones and all the telecommunications. So you see in the image, and these images start from about 2018, I believe. So the image to the left shows what in the night the surface area looks like. You can see the different cities, they have lots of light and so on. Now, if you take the image in the microwave band, you can see that there's much more dispersion of microwaves than there is of light. And I think this would be capable of distorting or modifying those xenic fields pathways that Tesla had found and were being described since by others and confirmed by an experiment, I think about 15 years ago, by Dr. Coram. So you're now changing on a smaller scale, a lower scale, and slowly giving more energy towards the ionosphere because of the way we use telecommunications. So it's a new source issue. Next slide, please. Now, here are some explanations of the antenna, the type of antenna that Nikola Tesla was trying to work with, trying to figure out, what happens at, say, 1 kilometer above the Earth, 2 kilometers, 5 or 6. Well, he had this beam, and this type of beam has become a subject of research about 5 years ago, mostly from the Russian Federation, and it's called a Gyroklystron. And one of the characteristics of such beaming, you can do in different ways, is that it doesn't dissipate. It isn't like it keeps on being strong. Nikola Tesla developed another form of this for his anti-war device, which had been the Star Wars type of situation. And it can use microwaves, can use light and so on, or even just simple electrons. In the case of Nikola Tesla, was using just electrons. And So you have this type of laser, if you wish, and it is quite remarkable. And one of the characteristics shown in the image below is that at certain distances, eventually that leads to other new products, if you wish, new plasma. Now, what is possible with this kind of knowledge, and of course in the hands of the United States Navy when they do the studies, and in other countries as well, I mean, it's not just the United States, it's completely controllable. There is no deterioration, it's lossless. It travels and transfers waves, as I showed you was done in the sky above Norway. It does not radiate, it's not a normal thing. And of course, first described by Nikola Tesla. And it can produce plasma at a distance where you want it. So that is a technology that is already here in one way or another, or being researched or experimented. And it's the kind of thing that will be seen probably more often for all kinds of applications, especially what it will be terrifying, that we're totally controlled by AI. Next image, please. Now, there's another aspect to all of this, which is very important, and that's the geoelectric field, the electric field around the Earth. I first heard about it from a Japanese scientist in the 1950s and 60s, who was an expert in this. He took an understanding of the planetary electrical field at any moment, anywhere in the world. And he noticed that when there were atomic blasts, the electrical field would change dramatically. And this was his pleading through the United Nations to have stop doing atomic tests. Now, the image that you see here was the image for the 5th of February. That's 4 days ago, of North America, and it's produced by the National Resources of Canada Department. And so every day there's a different image occurring and will have an impact. And we can assume that all the emissions that we make, both from satellites and to satellites and between and on the surface, can have an impact on the nature of these fields. Now, the image to the left that you see is the laboratory of one of our founders, Elizabeth Rauscher, who was a professor at Stanford University, and Berkeley, Lawrence Berkeley Laboratory. And you can see that already way back in the mid-70s, she and her colleague, William Van Weiss, who we have worked with very hard with, especially in Canada, to promote this research, especially for electromagnetic fields and the Russian woodpecker, were seeing already the dynamics of the electrical field on a planetary basis with these instruments, and they could detect things like the entry of a UFO, for example, or the launching of a rocket. It would immediately have an impact that could be sensitive, and it showed that any such incident has a planetary-wide instant response for the electrical field. Just to give you an idea how sensitive is the electrical field of the planet. Next image, please. Now, so I finished introduction to the nature of the planet from a physics point of view. But I like to point out that many people, of course, for a variety of reasons, sometimes from personal experience, sometimes from their learning or education, and or people who reflect on what does it mean to think, um, see that the world is not only physical as we see it, but is actually multidimensional. Now, and I think an example of multidimensionality that was referred to in one of my earliest slides was the incidence of the light bulb in the midst of the coil in Colorado Springs. Now, just like for the Gyroklystron technology, it only works if there's a triode situation, not a diode. Now, when you start doing things, for example, in triodes or more complex situations, what I think is happening, or even when you have field-free electromagnetics like the pathways of Zenek, you are involving things beyond the physical, like, there's no more field, right? What is being transformed? You're now capable of engineering with or relating with things that are multidimensional. Now, the image you see on the right gives you an idea of in any point of space, you have all these dynamics, and for electromagnetics and for physics, we only relate to a few of these. There's at least 20 different vectors, 20 different things can happen. And now, when you have between dimensions something happening, there is actually an experiment done for another purpose, which is shown on the left. Was showing liquid crystals between two lattices when they're interacting between themselves, produce a relationship. So as soon as you have one thing, you have a corresponding response, and there's an interrelationship with them. If it's in terms of charges, you can see on the middle graph that the one thing that started something, let's say the event of having the light bulb in Colorado Springs in the ground surrounded by a coil, it is now starting to react to something else. So there is a sort of a portal between dimensions. And with all the technologies that we're now shooting to and from the ionosphere, we're starting to relate to things that are beyond dimensions that we understand. And one of these dimensions happens to be the notion that I'm sure you've heard of, that there's anywhere in the cosmos, whatever happens in one place, there is a corresponding activity elsewhere. So which is what thinking is like. Consciousness involves that too. So we're treading into a situation where we are influencing the nature of cosmic events, not just the atmosphere, but the nature of cosmic events by the way we are interfering with the normal processes. What this means, I have no idea at this moment. Next slide, please. Now, to have some sense of dynamics that are multidimensional, it's very interesting to look at cymatics. So cymatics is a study done, I think, about 1960s, 1970s, where you would have a rather flexible plate, like, say, paper or some reasonably stiff but still flexible, on which you put, say, sand or salt even, and you make some music. So if you play, say, brrr, well, all of a sudden will pop up concentrations of salt or sand or whatnot. And if you have a certain type of, say, harmony or whatnot, you start even having, as shown in the bottom slide, these spirals of connection between things. And I think these are very suggestive of what things in multi-dimensions look like. So you can think the core sound that you see in cymatics, that is the cosmic mind, the actual cosmos itself. And it can produce in material things, in 3 dimensions, results. Now, what might happen by the way we're playing around with multidimensionality without realizing it, with gyroklystrons and all other things, and even is that we're creating new things. And this may also explain why some of the chemicals that we are sending to space, like nanoparticles and even moles and so on, and even polymers, are producing, when examined in the laboratory, producing new living forms that we have no understanding of. And because we're tampering with the natural flow of cosmic events. Next slide, please. Now, it's another way of trying to understand what multi-dimensional activity can look like is to use what is a wonderful, how can I say, actually, I would say science, that was developed in the late 1800s, and that is the notion of synthetic geometry. Synthetic geometry studies betweenness of fields up to any number of dimensions, infinite dimension, if you wish. And there's no numbers involved, no coordinates. This succeeds in doing what mathematics is not capable of doing. Mathematics is very much a thing that we live in 3 dimensions. We can explain this repeated, but we cannot explain, for example, the mathematics of, say, a card hood that you're designing, which has all kinds of curves and so on. It's very hard to describe it in some nice formula, algebraic formula. You can only make these objects the way we do them today by hand. We have to actually mold out on wood or plastic some shape that will become a car hood or a car roof or whatever. And for that you need synthetic geometry, which allows to add on little things like mathematical formula, etc., to say the hood. Like if you want the hood to have a low bent for for lamps, for example, car lamps, well, you can take a curve that is known, what has a known algebraic formula for it, but you cannot make one that gives the whole picture together. And a simple example of synthetic geometry, as it applies even for the ionosphere, is that you allow for parallel superposition. You can allow for, in any form, in any way, things to go in parallel, like the Birkeland currents that I mentioned to you, that provide a sheet through the North Pole of the planet. So that's one way of looking at it. And last year in May, Google reported that they did this kind of thing, which they call braiding, and they engineered it so that it could correct errors in quantum computing when they use what they call non-abelian anyons. So it's a way of overcoming noise. So that's already something that is now, this type of approach of synthetic geometry is now becoming part of AI and our understanding of making things better, more complete and capable of learning too. Next slide, please. Okay, so here it is, Planetary Association for Clean Energy. You have our email address, our website, phone number, and may I remind you that it was our scientists who convinced the government of Canada and the government of the United States that acid rain was real, that ozone depletion was real, and now I want to impress, hopefully that people will listen, that the destruction of the ionosphere is a possibility. Thank you.
Thank you for being here, Dr. Michrowski. Anyway, I've seen some of the stuff, like we were looking a couple slides ago. Kind of reminds me of nuclear blast there, and I don't know. You probably remember back in the 60s and 50s when they were doing atmospheric tests, you know,
Yes.
and I think they had one that was starfish, and I guess that particular one was the first time they really determined saw EMF on a global scale, and I don't know. Dr. Brandenburg.
I
Anyway, he spoke at our conferences before. But he told me that when they set that off, they knew that something was up because the ionosphere just totally disappeared.
Oh,
Or,
well, yeah, that's the intention of HARP. HARP was when it was intended to be was a military study. One of the things that they wanted to make sure was that because the Pentagon believed very much that communications is the key to everything, uh, is that they could destroy the ionosphere in by piercing it basically, and therefore there will be no longer wireless communication possible except our own system, which was another system of communication. So that will be one way of overcoming the enemy, is by being the only one with communication capability.
well, the thing that struck me though, that was a total short circuit, and that was pre HARP, because HARP didn't come back till what, uh, about the 80s, late 70s and 80s, and yeah, I put together a book on HARP too.
Yeah.
But that starfish, um, they're talking about now going back to atmospheric testing, and one can only wonder what implications that's going to have for us as humans here on the planet.
Well, we do not know. It depends on what's being used and how it's used.
And you've also been doing work with what electromagnetic sensitivity in people.
I don't know what you're talking about. I'm sorry.
When people can't handle being exposed to electromagnetic waves.
Oh, I see. Electrosensitivity. Yes. 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 Oh, that affects lots of people. Yeah. And there's a need to have all kinds of methods and uh, well, actually, many people. Well, let's put it this way: about 30% of the population of North America is electrosensitive, but then uh, of which about 5% are so disabled that they cannot work or they cannot even drive, for example, and they lose their jobs as well. And about 15% now don't sleep well, don't feel well, or continuously sick and have all kinds of situations that can even be seen as psychological problems. But it's a very real problem, and and we have a whole generation that's living with this.
I think it's going to get worse before it gets better.
That's
Uh,
right. I agree.
you know,
Do you carry any questions from your public?
right here we got one. Do you
Okay.
think there will be a pole shift?
Well, uh, there can be another way of looking at pole shifts, um, and that is that and this comes from archaeological and geological research done in the last few years, that there may be the kind of issues that the ionosphere was transformed. It's not just the pole or the planet changes pole; it's the entire thing, and this we can be in a way of provoking something that would look like that. By the way, that was the explanation that's being given recently why dinosaurs disappeared. Basically, that it was something like a massive change of the ionosphere in one instance. But uh, but one
Another
can predict. There's always drifting going on. The planet is changing shapes. There are very interesting issues happening now between more or less the border of Turkey and Syria, onto northern Iraq, and there's a sort of a splitting up. It's not an earthquake fault. It's literally a splitting up between two zones, and that's it's manifested itself like the Santorini earthquakes we're having these days. It's not an earthquake situation; it's a splitting situation. So between plates, and with that, there are gravity anomalies, and there are also which affect people in the sense that people become more agitated. And I think that's showing up with all the conflicts that are in that area as well. And that started more or less in the 1950s, this shift, where the gravity anomalies between the north, especially towards Europe, and the extreme anomaly in the south is the tip of the Persian, where the Persian Gulf starts into the ocean, and that is creating an imbalance. So this is also an electrodynamic situation, not just an ordinary. And it's the kind of thing that we can associate ourselves mentally what one would call a polar shift. Okay.
Here's another one. NASA blocking our sun, chemtrails. How can we get them to stop?
Well, it's become an industry. Lots of people get a job this way. I do not know. Like our association, we were only about a few hundred scientists at that time, managed to convince that acid rain was a problem, and then the ozone layer depletion was the problem. Maybe we can have a realization that we have to protect the ecosystem that our ionosphere has, and that one thing that's not helping the ecosystem with the ionosphere is chemtrails. Not to mention whatever it does to human beings or life. I think it's presenting the evidence, talking about it. We have a situation also too that our association was involved because we have an office in Geneva in Switzerland at the United Nations level, and we were able to get at least a protocol accepted in Nagoya, Japan, for geoengineering. And the protocol was accepted in general. It's not been implemented yet. Some countries wanted to reserve their permission to use geoengineering. But what happened with that thinking is that there are actually organizations, both national, like the United States, but also World Meteorological Organization, that have allowed chemtrails to exist and geoengineering with chemicals in any way. And that's become a movement where you have a whole infrastructure of thinkers and policymakers who are pushing for a thing that is very hard, and they're very well encrusted. It's hard to bend rules, See, I'll tell you how we managed to control acid rain, okay? And then the ozone depletion. In both cases, colleagues of ours, one of them you may know, Andrea Puharich, were able to go literally to the Prime Minister's office, literally go into the room to see the Prime Minister of Canada, in both cases, to say, hey, acid rain is really a problem, here's the proof, and here's the proof that ozone depletion is the problem. And that was enough to start that maybe diplomats would say, hey, why don't we have a conference? Why don't we check into this and so on? And eventually there were agreements made, like for example, for ozone depletion, not to have certain additives available in certain chemicals. So, but it's now very difficult to think of a situation where anybody can just pop into the office, say even Trump, who may think differently, or even the head of the European Union, or even the Secretary General of the United Nations, say, hey, this is really a problem. Why don't you look at it and just think about it and check it out? That's no longer possible. We've become too concretized, but we can try.
Okay, here's another one. What do you make of the South Atlantic anomaly?
Yeah, that's one of the things that can be tapped for if you use technologies such as I described, and which are probably being used anyway, which can explain why it was so easy to change that certain storms do not hit the United States, but instead hit Europe. It becomes a sort of a sinkhole, energetic sinkhole to borrow energy from.
Okay. And then here's one. NASA created by Werner von Braun, Ionosphere. Why is it allowed to go on?
Well,
I think NASA is a good thing. I mean, and I think that
NASA didn't exist yet in that sense. This was part of the paperclip program, but and eventually that became NASA when Kennedy, wanted to have some space exploration. But
well, have you noticed that?
I think what has happened is this, okay, because it has happened on another front. It happened for electromagnetic fields too. After World War II, for example, for electromagnetic fields, there was a German scientist who actually tortured people with microwaves and see what temperature would be necessary to blow up, say, a liver or a heart or whatever on living persons. And this guy was invited by the United States Navy to help, quote unquote, develop standards for electromagnetic field exposure to U.S. Navy and U.S. Military working, say, with radar installation and oscilloscopes. Okay, basically, they wanted to know what was safe and what. So this guy was invited. He took all the information he could get, bring with him to the United States to show at what level does skin start to burn, at what intensity, and if it's pulse, if it's a sine wave or whatever, and then that's not what we don't want. Everything below that is okay, and that's what became standards now. So I think the United States may have been, and Russia, as Soviet Union at that time also, were very interested in the kind of people like von Braun, because that was an area in which they felt they were weakened. And they say, well, here are the experts. We just allowed them to work without giving consideration what was the ethics behind even that science, and understanding. And of course, in the light of everything, especially with people like the background of Tesla and his knowledge that he was already providing the United States, we would have never needed to have rockets in the first place. We could have done things otherwise very early anyway.
Okay, well, I'm gonna call it a night there, and I'd like to thank you for being here and everything. And I think our guys are starting to get too political here, and I hate to see politics in the science. It never gets to no good. But anyway, thank you for coming. And I'd like to remind everyone we do have a conference coming up, and if you get a chance, get in there and get signed up for our YouTube channel. At least become a subscriber. It's free. And if you become a member, it really helps us out. It's $9.99 a month. And we really appreciate your support. And anyway, thank you again. And I'll see you guys all next week on Steve's Place. Thank you for being there.
Thank you.